Hi, good afternoon. I will continue a little bit where Jim left, but Jim addressed mostly the high school courses, and I will go down below into the K through 8 continuum. And I will start actually at looking what would a success look like. And those are the major things that I would like to see: increase advanced math course taking, increase success, and closing the gap. Closing the gap by raising the floor, not by squishing the top. And remember also, we mentioned, Jim mentioned the Tom Lovelace today, that there was enormous increase in algebra taking without corresponding increase on NAEP scores. Many of these courses have names like Algebra 1, Algebra 2, but the content has been diluted. And that's why I stress the authenticity of the type of math courses. Now, I think Massachusetts Miracle was mentioned, and Sandy was instrumental in making it happen. And we all know that Massachusetts moved forward and stayed there up on the top. And that's wonderful. They had great standard, and they had excellent implementation. We also know about California that had supposedly great standards, but somehow the achievement didn't follow. And a lot of people ask, how can it be? Don't the standard matter? Well, actually, there were two things that happened in California. Sorry. Okay, this is a chart of California schools in 2004, the first year basically that we had scaled scores. And you see on the horizontal axis the percent of taking algebra in any given school. And on the vertical scale, you see the average achievement. And you have also the dotted lines that show basically where the school fell based on the percentage of math taking. Now, it's quite natural to see that as you go forward, you would think the scores will drop. And indeed, this overall distribution of dots shows exactly this pattern. So this says, well, you cannot have 100% algebra because the scores drop like a rock. That's what you would think. And there are very few schools who have one here maybe, but just one school had the advanced, which is 500. This is not very high advanced even. And it was close to 80% maybe. This is the 2004 data. Sounds kind of ominous. It's not going to work because California said in 1997, we will expect what all the foreign countries that are high achieving expect, algebra by grade 8. We'll not do it overnight, but we'll push. We'll give incentives, accountability system to go there. This didn't look well, very promising in 2004. Now, look at this picture. 10 years later, less than 10 years, 8 years later, suddenly the picture has changed. Suddenly, a lot of schools are here in the high numbers, and the scores are pretty high, some of them very high, much higher than the previous 500, there are even 550. Excellent movement. And those are school results, not tiny schools. I eliminated charter school and I eliminated tiny school that had less than 60 kids in 8th grade. So here are the results all together. Look at the huge change. Those are not just more kids taking algebra. Those are more kids taking algebra successfully. So how come our scores on NAEP didn't change? This is another look, by the way, in the same data. And what you see here is, in the first years, we didn't have really the scale score, but starting here, we had some scale score. And you see, this is the fraction of proficient and advanced. Those are good results. The middle one is the basic, which is kind of ho-hum, and the purple is really not good. And the purple stayed steady at a certain point. In fact, it dropped recently, while these numbers kept going up. So while in California, We expanded the number of algebra taking by fourfold since the beginning. The average fraction of proficient and advanced, not just basic, proficient and advanced, kept growing up. And the actual numbers are astonishing, because we had, from 52,000 10 years ago, we have over 160,000 today. 170,000 students are proficient and advanced by grade 8. It can be done. Common Core says, no, you cannot. Now, is it only Algebra 2? People will say, well, Algebra 1. Algebra 1 doesn't translate necessarily into Algebra 2. Well, this is Algebra 2 by the end of high school. Same pattern, less pronounced, but still, you see the numbers are growing and the success rate is growing. So it's not like the more takers, the grades drop to the floor. In California, did not happen what Tom Lovelace correctly, I believe, observed across the nation. So it sounds wonderful. So how come California results are still not so good? Well, maybe the test has changed. The California test doesn't reflect the reality. Actually, the test has not changed. Bill Evers and myself, we sat on this panel reviewing the test items and the test composition since its inception. The test did not change. Demographic has changed. Now, it's well known, unfortunate but well known, that certain disadvantaged populations had lower achievement. As the number grew in California, California overall results, which is normally what you see on the NAEP, were stifled, were reduced, attenuated. And now I'll have some data on this, because just saying it doesn't make it so. You see the numbers. But before we go to the numbers, how come, or what was the key? The key was good K-7 standards, because you cannot expect kids getting the same old K-7 standards and then suddenly in grade 8 jump into algebra ready, like Athena. No, they have to be prepared, and our standards in California from 1997 prepared everyone, expected everyone to be ready by grade 7 to take algebra in grade 8. Now, here are the numbers. And here you see not only Algebra 1, but Algebra 2 and Geometry taking for different 4 sections of the population, the low SES, the ratio between 2003 and 12, the African American, the Latino, and the white. And you see that the huge increases are here and here, not here. Same in Algebra 2. There was explosion in advanced math taking in high school in California. Successful. Those are only proficient and advanced, not takers. Proficient and advanced, achieving on a rather rigorous test. Those are enormously successful numbers. And look at the table in the middle. The ratio from low SES between this decade, basically, was much higher than the ratio of the white increase. Same for African American. The minorities, the disadvantaged population, was the biggest winner of this change because the K-7 population. The more affluent student, the student that had support at home, always got this support even without the K-7 standard. So they got their tutoring at home, they got tutoring outside by professionals, and many of them made the algebra anyway, and then the more advanced courses. But finally, with K-7 preparation, everybody got this readiness if he was just willing to learn and the teacher able to teach. Not always happens, but huge increase. Those are basically plots of the same data over time in logarithmic scale, so you can see how the ratios actually reduced. And indeed, the gap closed significantly between all the disadvantaged population. So this is an incredible story that most people don't see. They say, oh, California, you know, was number 48 of the 50, 90, around middle of the 90s, and now it's maybe 10 points up, maybe it's in the bottom 10, not bottom 2. Well, bottom 10, but if you calculate in the demographic change, it probably should be somewhere in the middle of the pack. And that was a huge advance from the bottom of the pack. Anyway, so what does the Common Core do? Well, they say Algebra 1 is not really for grade 8. We don't do what we expect, what other nations expect. We do much less. We expect them to take algebra by grade 9. And yeah, if somebody can make it in grade 8, maybe some state will offer an option. But who will be in these accelerated courses? Like 15 years ago, mostly the affluent students, not the disadvantaged student, not the minority. Early algebra is the key. And we should remember this, that Common Core basically took it away. And this is not what other countries are doing. Which brings me to what the Common Core proponents claim. The standards are focused, coherent, clear. They are anchored in college and career readiness, and we saw something about that already. They are evidence and research-based. We saw something about that. And they are internationally benchmarked. Well, when Common Core people were asked to defend the rigor of the standards in a public forum on the pages of Education Next, the editor couldn't find anyone from the Common Core willing to step forward and discuss it. If they're so rigorous, how difficult it is to defend them? And this is recent from the College Board, a vice president in charge of AP. He said, AP calculus is in conflict with the Common Core. And it lies outside the sequence of Common Core. And you heard the implication right now. So it's not only that the schools, the high schools, will not have these course offerings. College Board possibly will remove the availability of this test. So they will not push from this side either. There is no measuring stick. They removed the measuring stick that was one of the yardsticks that we used to measure the progress of schools. And the last statement is by Bill McCallum that the standard is indeed, are not going to be indeed too high, which is in line with what Jason Zimba mentioned in the clip that you saw before. I'm going to skip this if you don't mind. Jim Milgram talked about the college readiness. And here is the other aspect. Michael Kirst, he's currently the state board president, state school board president in California, but he's a professor emeritus at Stanford. He was chairing the committee of NAGBI, the NAEP governing board, to figure out if you can have the same standards really reflect both college readiness and career readiness. And he said, to my knowledge, no, and certainly the writers of the standard didn't present any evidence. Well, they declared it by fiat, that they are one and the same. There is no evidence behind it. And the evidence we saw today shows that they are below academic expectations. So maybe they are career ready. They are certainly not college ready. And then we have 5 studies that did international comparison. And one is from Jonathan Goodman at Curran that find it significantly lower expectation, the Common Core, compared to other countries. Sandra Stotsky and myself published in 2010 a review of Common Core and found about the same. Our own Jane Milgram here testified in front of California academic content standard and said the same thing, that the Common Core is eventually by middle school, by grade 8, 1 or 2 years behind. And I want to stop here because a speaker before lunch mentioned correctly, I think, that the Common Core is expecting so much more in very early grades, unreasonable expectations. So how do you reconcile this with suddenly us Jim, me, saying, well, grade 8 is already 2 years behind, why am I behind? How does it hang together? The fact is, both statements are true. It's strange how it was a lot of very ambitious content was pushed down to kindergarten and grade 1. Thing that Singapore does in grade 1 and 2, where we push to grade kindergarten and grade 1. Very, very aggressive. I do agree with the previous speaker, it was possibly unwise. However, by grades 3 and 4, things start to repeat themselves and slow down. And when you reach middle school, they barely move. And then in grade 7, they jump a little bit, and then in grade 8, they jump a little bit more, but by then, they're much behind. So there is this weird thing that on the first look, you say, how can it be? The first 2, 3 grades are super ambitious. And then it goes slowly. And that's how we end up where we are. And that's what these studies found. Then there was a study by Andy Porter, who is a dean of education graduate school at University of Pennsylvania. And he also found that the Common Core standard have much less behind them than one would imagine, and they are not looking good compared to other countries. And finally, just less than a year ago, there was a study published by Bill Schmidt and Huang from Michigan State. Bill Schmidt was on the validation committee, and he did sign off on the common standard. And he actually found that the standards are rigorous, that they are comparable, and there have no major differences between them and the Common Core. So his is the only study that finds suddenly Common Core being very challenging, on par with the international standards. How did he find it? We should look at this study closely. He took the Common Core standard and mapped them based on a methodology he used probably 15 years ago when he was the coordinator of the third International Math and Science Study, TIMSS, in 1995. And he did the same thing with Common Core as he did with the TIMSS high-achieving countries. And he found them, as I said, very consistent. And he claims that states that have standards similar to those that, like Common Core, also do the best on NAEP. And therefore, he found the Common Core is coherent and hierarchical. So let's talk about TIMSS. As I said, it was happened in 1995, a lot of international data. The top 6 achievers were taken and dissected, and the curriculum analyzed and reviewed. And the conclusion was that those high achievers, the so-called TIMSS A+ countries, have very coherent sequence of development of mathematics. It's very focused. So you don't teach a particular subject for many years, but you teach it. You go in, teach it for 2, 3, 4 years typically, and then stop, and then go to the next subject. But you teach it to mastery. And while you teach it, you teach in depth, not just superficially, because you don't come back to it over and over again. Very reasonable. And in the late 90s, this mile-wide in-deep thing came to be known, and it came from here. And this is how the topic progression looked like of the original TIMSS A+ countries. What you see here is, those are the topics. So you start with whole number meaning, whole number operation, fraction, 2D geometry basic, polygon and circles, and blah, blah, blah. And it goes down, basically covering the K8 curriculum, actually 1.8. And here are the grades, grade 1, 2, 3, 4, 5, 6, 7, 8. TIMSS started from grade 1, they did the analysis not from kindergarten, various reasons. And the coherence is embedded here. You see they start early with the easy topic, the fundamental topics, and they build on them and they stop them at a certain point and introduce new topics. And you see this characteristic triangular shape, kind of, that shows the progression, the logical development, and the coherence. Now, I said logical development, coherent sequence. The orders of the row is very important. Clearly, you cannot teach something much more complex before teaching something much more basic. So the basic topics show up there. Whole number meaning, whole number operation, a measurements unit, and equation and formulas are introduced only in grade 3, and 2D geometry is introduced only in grade 3, but 3D, for example, is introduced here in grade 7 and 8. Just makes sense. That's the coherence. So this picture is very, very rich in detail. As long as the sequence of the rows is coherent, because it makes sense, and people analyze it and verify, yes, it works. Okay, so Bill Schmidt did the same thing. Here what he did, he took the common core and he mapped them, here, the common core, in very similar way. And he says, look, the pictures look the same. Similar, not the same, but similar. And in fact, they do. They are very similar if you kind of look at them. Yeah, maybe you can say this is a bit more years for some certain topics, but that's understandable because these are only topics that the majority of these 6 countries had in their curriculum, but there were some topics that were outside, you know, only 2 or 3 of the 6 countries had, so they don't show up here. So this is lean and mean, this is a bit more fully fleshed. That's fair, they look the same. Makes sense, right? Well, in fact, that's what they say. They look the same. After introducing these 2 tables, this is the quote from the article they published. Looking at the visual in presentation, we note that figure 2, which is the second one that I showed you on the right here, and figure 1, the original one, at least in terms of general shape, from this point of view and vetting, blah, 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 the Common Core state standards in mathematics are coherent and focused. Wonderful. There is a problem. The order of the table on the right was changed. This was the original order, and I colored them, and here are the original orders. So suddenly here you see things like 3D geometry, which is here, is before 2D geometry basic. Does it make sense? Teaching about fraction, characteristic of fraction, where it is, something. I think it was here. Relation of common and decimal fractions are introduced before decimal fractions themselves are introduced. I mean, he messed up the rows to achieve the shape he wanted to shape. And then he talks about how the shape is the same, and therefore it is congruent with what the TIMSS A countries did. Finally, this is a scientific article, he couldn't avoid it. He did this table, this is table 3. And he puts the dots are supposedly, they represent the original TIMSS sequence, but in the new order, and the shading is the common core. And it kind of looks triangular because the shading catches your eye. But here is the highlight of the sequence of the original dots. The same picture as before, just I highlighted now the original sim sequence, not the shaded thing. Now this catches your eyes. Do you see the shape? Triangular shape, organized, coherent, progressive? I don't. And then he said, after introducing this figure without the highlighting, he says, there being no major difference between the 2 sets of standards, this provides further evidence that the Common Core standards in mathematics are coherent and very consistent with the international benchmark. He also says, and he counts, that he has 85% degree of alignment, consistency with Common Core, with the TIMSS countries. Well, if you count the squares that are not overlapping, you get almost 50%. So what Bill Schmidt comment on my critique, oh, you should have to divide it by the whole table, not just by the squares that are filled by one or the other. Well, in that case, if they're perfectly overlapping, here they will have at most 45% alignment, because about 45% of the squares are ever filled. he is basically fudging. I will skip this one. Here is the last claim in his study. This is his table. And on the top are states most like Common Core state standards. On the bottom are states that have the least like Common Core state standards. Their own standards, I mean. Their own standards are least like the Common Core. On the top, they are the most like on the Common Core. So, for example, by his own grading, Alabama is very much aligned with Common Core, and Michigan, and California, and Minnesota. And remember, he said, part of his conclusions, that the more the state standards are similar to the Common Core, the higher achieving they are. Therefore, he predicts success for the Common Core. Well, here are the red are the bottom 10 achievers on NAEP. In red, in green, there are the top 10 achievers. How many of the top achievers you have on the top? Only one. But you have many bottom achievers. So even the claim that if you are aligned with Common Core. Now, he goes and does some gymnastics. He's a statistics professor to some degree, his background. So to introduce another variable to show that it still is correlated, trust me. Well, you can trust him. The bottom line, we had 5 studies trying to make comparisons. 4 of them found the Common Core standard lacking in comparison to international high achievers. And 1 study doesn't hold water. And it was indeed signed off by Bill Schmidt 3 years back that they are on par with international benchmarks because he was part of the validation committee in ISANO. And 3 years later, he produced this paper to prove that he was right 3 years before. Okay, we'll stop here. Thank you.